Look at this fool. Okay, skill 13. Choose A and B so each is greater than 10 and they form the legs of a special right triangle. Bam. 12 is greater than 10 and they're the same length, so it makes 45, 45, 90 triangle. So that's what I got going on for me so far. Then part A is Z is equal to A minus BI. So when you plug that in, it's Z equals 12 minus 12I. And then they added the 7, so it's 7 to the Z to the 7th, and then 12 minus 12I to the 7th. So then from there, well, we know that the angle that the triangle made has a reference angle of 45, but it's 315, so it's down here, going this way. And the theorem states that r cosine theta plus I sine theta n is equal to r n cosine n theta plus I sine n theta. So what we got from there is you use the 45, 45, and we find the hypotenuse, which is 12 root 2, and we know that n is 7, so we plug in n, theta, and r to the formula, and we get this. Yes, and then that equals this here, or no, we get this equals 12 root 2 12 root 2 to the 7th cosine 7 times 7 pi plus I sine 7 over 1 times 7 pi over 4, which is right here. And then after multiplying these out, you get this equation right here, which is 4.05 times 10 to the 8th cosine 49 pi over 4 plus I sine 49 pi over 4. So we know that Z to the 7th is equal to that right there. And then for part B, we had to find the n roots of Z. We have to use the formula when k is a whole number and it's between 0 and n minus 1, and since n is 5, it's going to be 0 and 4. So then we use this equation right here. And this is why I used 5 for this one. And when k equals 5, you just plug it in, and you plug it into your calculator, and you get all the you just plug in 1 through 5 for n, and then that's how you find the values here. It's always going to be 1.76 because that was the constant we found from solving. And then cosine of 63 for when k equals 0. And then from there, we had to have 360 divided by 5 because there's 5 different angles, and that's 72, so that's what you have to add to each angle. So if you just wanted to do that, you just change the angles by 72 each time, and then that gives you all of the roots, the 5th roots of 12 minus 12i.